Hey everybody, so I have a couple of tips for you on this packet, the atomic structure, the Bohr models that I asked you to start looking at on Wednesday and doing this packet yesterday and today. So I want to give you some advice. First of all, if you haven't gone through the slideshow on Schoology, the first 10 slides of that slideshow that are in the week 2 packet, that says Bohr model and Lewis dot diagrams. If you haven't gone through the first 10 slides of that slideshow, you need to do that first. Don't try and answer these questions without going through that slideshow. The answers are in there. If you've done it once and you tried this and you're still not getting it, maybe try and go back and do that again. Okay, so that's my first bit of advice. On the first page, most of this is review and or directly from the slideshow. So go back and review that. The only part that isn't really is the answer to this question. It says, what term is used to describe the electrons in the outermost energy level? That's on slide 11. I'll tell you right now, they're called valence electrons. We'll learn more about them next week. Okay? So what I really want to spend some time on is how we draw these Bohr model diagrams. So I've picked 2 of them from page 2, neon and silicon, and I want to go through those. First, we'll do neon because it has fewer protons and fewer electrons, and it's easier to draw the Bohr model diagram for neon. Okay, so first of all, we need to know the information that's up here. The atomic number and the mass number for neon. All right, the atomic number is 10, and the mass number for this isotope of neon is 20. So let's answer these 3 questions first. How many protons, how many electrons, and how many neutrons are in an atom of this isotope of neon? First, we'll start with protons. The atomic number is 10. So how many protons is that? I'll give you a second to think about it. What you should know by now that the atomic number tells you the number of protons. So if the atomic number is 10, the number of protons in the nucleus of the atom is also 10. Now, the next question, how many electrons are there? Because in order to do a Bohr model, you need to know how many electrons you have to draw in there. So how many electrons are there in a neutral neon atom if it has 10 protons? I'll let you think about it for a second. If you think the answer is 10, you're right. Because in neutral atoms, the number of protons and electrons is always the same. So atomic number means 10 protons, so there are also 10 electrons. Now the last question is neutrons. And remember, to find neutrons, you subtract the mass number, you subtract the atomic number from the mass number. So mass number 20 minus atomic number 10 tells us in this isotope there are also 10 neutrons, because neutrons plus protons always adds up to mass number. All right, now that's review. That's review. The new part is this Bohr model. And what you need to know about the Bohr model is that electrons arrange themselves in energy levels, farther and farther away from the nucleus as you get more and more electrons. This inner circle represents the first energy level. The first energy level is the closest to the nucleus. And because it's so close to the nucleus, it can only hold 2 electrons. So we're going to put an electron here and an electron here. Now you might ask, Mr. Morgan, is there a reason you put them on opposite sides? Yes, there is. They tend to try to stay away from each other. Not always perfectly, can't always do it exactly the best way possible, but when we draw them, we try to keep in mind that like charges repel, negative electrons tend to try and stay away from each other. All right, so those electrons are like that. All right, now that's 2 electrons. So if neon has 10, and we've already drawn in 2, how many are left? Take a second. It's really as easy as it seems. Neon has 10 electrons, and we've already had 2. That means there are 8 electrons left. Well, it just so happens that the second energy level, being farther away from the nucleus, and you can see it's a little bigger, right? The circle's bigger. It can hold more electrons. The second energy level can actually hold 8 electrons. Well, that's great, right? Because we started with 2, we need 8 more, and this can actually hold 8. So we're going to draw 8 electrons in that second energy level to have all of neon. So again, I'm going to draw them as far apart from each other as I can. That's 4. I got 4 more to go. I'm going to put them up here, up here, up here, right here. And that's about as far away from each other as I can get them. But again, count them at the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons, 10 electrons. That's what the Bohr model for neon looks like. All right. Now we're going to come over here and do the same thing for silicon. Okay. The atomic number is 14, so the number of protons is 14. Since it's a neutral atom, what has to be true about the number of electrons? Yeah, the same. Protons and electrons are the same. And then neutrons, again, is mass number minus atomic number. 28 minus 14 is 14. Do the number of neutrons always equal the number of protons? No. They happen to in these two examples, but they do not always. The number of electrons always equals the number of protons in a neutral atom. But that is not true for neutrons. It depends on the isotope that you're working with. But in these two cases, it has, so that's fine. All right, now we've got to draw 14 electrons. So let's start the same way we did over here with neon. The inner level, the first energy level, can hold how many electrons? How many? If you said 2, you're right. So let's draw 2 in there. Okay, we've drawn 2. We need 14, so we need 12 more. Okay. The second energy level can hold how many electrons? 8, remember? 1, 2, 3, 4, 5, 6, 7, 8. The second energy level can only hold 8. So let's draw 8. Okay. Here's one. Here's another one. 2 more. And then that's 4. So 5, 6, 7, 8. So that's 2 plus 8 is 10, just like we had over here for neon. Are we done? No, because this is silicon. Silicon has 4 more electrons. It has a total of 14. We've done 2 in the first level, 8 in the second, that's 10. So now we need this third energy level. So how many can go in the third energy level? Well, actually, it's a little bit tricky with the third energy level, but for now, we're going to say also 8. 8 more can go in the third energy level. How many more do we have left? We can fit 8 in the third level, but how many more do we have left? Well, we need 14. And so far, that's 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need 14. We've done 10. We need 4 more. So let's put 4 more in that third energy level. 1, 2, 3, 4. And there you go. That's what the Bohr model diagram looks like for silicon. Now, you can go back and watch this video again and again and again. Keep trying it until you think you get it. But really, more than anything else, don't freak out. All right, relax. If you've watched it a couple of times and you think you've got an idea, try the other 2. There were 2 more on this page, magnesium and chlorine. Try those. Remember, you don't have to do the Lewis dot diagrams at the bottom yet. We'll do those Monday and Tuesday. But for now, just finish up this page, these Bohr model diagrams, and next week I'll let you know how you're doing. Okay? Good job, everybody. Have a great weekend.